Hello, good morning or good afternoon, depending on where you are, which side of the Atlantic. Welcome to this webinar. Today, we're going to spend some time talking about how to effectively use and manage container workloads from a performance management and capacity perspective. So we'll jump right into it. If you have questions throughout the webinar, you can submit your questions in the chat window of GoToWebinar, and I'll pick them up at the end of the session. I think we have time for some questions at the end. That's my hope, at least. So if you're wonder what I look like, this is who I am. My name is Per Bauer. I'm Director of Technical Services at Help Systems for the Vityl Capacity Management suite or product. I've been with TeamQuest before Help Systems for many years, and I've do several of these, so there's a good chance that you've heard me talk about these kind of matters before. So today's session we're going to spend on these different topics. So we're going to start by giving everyone a quick sort of repeat or introduction to containers, level set, and make sure that everyone is on the same page. And then we'll discuss some of the changes that brings to how we do performance and capacity management. So some of the considerations you'll have to look into before you move ahead and put them in production. And then at the end, of course, as I said, we'll do a wrap up. And if there's any questions submitted by then, we'll definitely respond to that or try to answer those as well. There will be a couple of polls throughout the webinar as well, where I bring up a poll and you are, I ask you kindly to submit your answer to that poll. So, what is containers? At the heart of it, I mean, it's basically a form of virtualization. It's an operating system level virtualization, meaning that the hypervisor is not separated from the operating system, like VMware ESX, for example, which is a standalone hypervisor that manages operating system instances. This is inside the operating system. So the operating system, in this case Linux, has a number of mechanisms like C groups and namespaces that is used to provide this containerization concept. It's been around for a long time, but it hasn't been productized or been used to the extent that it is in later years. But it offers the same level of isolation and resource management and portability as virtual machines, basically. So it comes in, when containers became a hot topic some 4 or 5 years ago, it was mostly centered around Docker. Docker is basically a container runtime engine or container runtime image, which was made very popular by the company Docker, and it became the de facto standard for how to run containers. In the recent year, I would say, there is a new initiative called OCI, Open Container Initiative, that is competes with Docker. Basically, it's an open format for container images that is starting to get some momentum, and the future will have to show where it all ends up. But Docker nowadays is basically it's part of the infrastructure or part of the fabric, but it's not really a product that is determines how you're going to run your containers or how you're going to manage your containers. The difference between a hypervisor and a Docker or a container-based setup is, to a large extent, is the resource allocation that is needed on the system. So a virtual machine is basically everything from the guest OS up to the application, whereas the container is much more lean. It has a container engine that is shared between all the different containers, and then the container only contains the binary and any libraries potentially that would be needed for that, and then the app on top of that. That means that you can save resources in terms of how much you have to allocate for this. So you can save money by provisioning less infrastructure. There's less overhead for running the containers, but there's also license cost, of course. The commercial alternatives around virtualization becomes quite a substantial part of your overall cost, whereas containers, all the products more or less that are associated with containers are community-based or open source, so there's no cost for them. So why are people using containers, or why is there such a hype around it? It makes it easier to package and deliver services or applications, same way as VMs did, but it's a leaner format. You don't have to have all that overhead with your own operating system image, which provides the flexibility to run the services anywhere, so you can package them in containers and distribute them much easier. It also fits very well with this continuous integration and delivery process, where you move towards smaller components of software like microservices, or something like microservices, where you release more continuous, smaller piece of your software, and by that you can control the impact of those more frequent releases and work in a completely different way. That in itself is a different movement, but containers happen to show up at around the same time and was a very good combination with the CI/CD way of developing applications. It also speeds up development, but because you can use these predefined images. So if you want to have standard components like Nginx or Redis or FluentD, etc., pushed out to a large set of different nodes or hosts, it's fairly easy because you can find these predefined images. You don't need to build them yourself. You can use those prefab components and push them out. So those are a number of reasons. I mean, there's probably more, but these are the ones that are most prevalent, I guess. So as I mentioned, this containers happened to coincide with the whole movement towards cloud native architecture. So adoption of public cloud and private cloud for that part means that a lot of applications are being refactored to become more cloud native. So using microservices, supporting scale out, automation, etc. And that rhymes very well with containers. Containers is highly, you can automate the management of them to a very large extent. And it provides all these, small components, microservices that scales out, etc., etc. So it was, the timing was absolutely right when it arrived, and that's probably why it became so successful. Since the early days of containers, the focus has sort of shifted from Docker, as we mentioned, as a standalone container image format that you were running your application in, to orchestration software, orchestration and management software. So automating the deployment, scaling, and operations of containers across clusters and hosts in production. So anyone who runs containers in a production-like environment are using one of those orchestration softwares. And most likely they are using Kubernetes. Kubernetes has surfaced as the has become the de facto choice for orchestrating containers, Docker containers. Kubernetes is a Google project. It's a community-based open source project, so it's free and it's very powerful. Very the learning curve is somewhat steep, but once you get the hang of it, it's really powerful, and it can orchestrate really large implementations of Docker containerized workloads. Its focuses on, or its use is what's called, often referred to as desired state management, which means that you basically describe how you want your application to look like, or how your architecture should look like. So how many different containers of different sorts puts in what they refer to as pods. How many of those do you need? How many replicas do you want for high availability or failover purposes, etc., etc. And then the cluster service takes care of this for you. It has a number of nodes where it puts the software, and then it manages that for you. So you don't need to care too much about where different containers show up, etc. This also means that you lose some of the control. So once you've told the software to do this for you, you leave it at to do this, and that means that you let go of some of the control, and that makes from a management perspective makes it a bit harder sometimes. Container frameworks or container services are available from all the public cloud providers as well. So AWS, Azure, Google Cloud, they all have out of the box, either Kubernetes-based or native cluster management platforms that they deliver as a service. So you can certainly migrate your, container-based workloads over to cloud without, having to do any kind of reconfig or rewrite of your application. Okay, so now it's time for the first poll. I'm gonna see if I can find it here and bring it up. Just a second. Okay, so now you should have a poll in your window asking, how would you describe your current container usage? So I haven't started using it at all. I'm evaluating for future projects. We're currently use it in dev and test. And then the last one, already using it in production environments. So I'll give you a few minutes to respond to these before I show you the results. So please vote while it's still open. Okay, I think most of you have responded now, so should be able to see it soon. So I think you can see it by now. So there's 40% haven't started using it at all. Surprising 0% or none of you are evaluating for future projects. That must be a coincidence that we happen to catch you during a time when you either haven't started or you've brought it into dev and test. 40% are in development and test, so you're evaluating it for future use, and then 20% already using it in production environment. This is pretty significant, or this mirrors my perception of where the market is to lie. I think the share of organizations that haven't started using it at all, the 40%, that is probably slightly higher than I would expect, but the other ones, are in line with my expectation. If I would have had a guess, I would say that maybe 10 to 20% would be in the first category, and the rest of them would be in the second. But you never know with these kind of polls, but it's relatively expected results, I guess. So, okay, thank you for participating. So we'll move on to the next section. So we're talking about containers, what it is, what it means, how it's implemented, etc., etc. So what is then the impact on capacity management? It's in many ways it raises the bar for what you need to do in your capacity management efforts. There's a number of challenges that it presents to you. The first one is the obvious one, so observability. It's a new set of components, new set of technology with new instrumentation, and you need to pick up that instrumentation. Capacity management relies on data, as we all know, and you need to have that data in front of you. You need to scale up your efforts because you're going to have more moving parts. You also need to be aware of the shorter lifespan of containers. So, the frequency of your data collection and how long you actually save the data, etc., will be impacted by that. Since you have more components and it's more fragmented, you need to aggregate things up to a level where it makes sense. You need to provide context to that fragmented picture, and then you need to, there's some changes to your operating model, most likely, because, due to the adoption of containers that you need to be aware of and you need to take care of. So let's move into those. So what do we mean by observability? So you need instrumentation, you need data about how your containers are working. Containers, as we all understand, competes for host resources, so they are running on a host. There's nothing new there. Of course, you need to understand what type of resources, CPU, memory disk, etc., is being used by a specific container or a group of containers or a type of container. That instrumentation exists either in the operating system, so the kernel of the operating system, because underneath the container there is actually a process running on the operating system that needs to be monitored or that consumes resources. And then you have also get data from the container engine through an API. So whether it's Docker or it's another container engine, there is an API that provides some metrics around how the different containers are consuming resources and what the potential overhead of the engine in itself is, et cetera, et cetera. So you need to understand how much it is used, and what resources are being used and by who are they used. And you need to save this data either for long-term analysis, but most likely, if you at this level, at the container level, is more around sort of real-time or near real-time observation. So to find out, what is the trend, what are the cycles, what are the patterns of behavior, etc. for those. What this means, it depends on your platform. If it's a physical host where you're running this, which is mostly the case, I would say, but it's not the only scenario, you have to understand, so how much is the containers using, what is the container engine seeing, what are we seeing from the operating system, and what are we using in terms of physical host. All of that we will bring you through Vityl Capacity Management. We have data collectors that provides data from all those different levels. In a virtual environment, there's a couple of extra levels or extra tiers in this. There's the operating system, and then there's the virtual machine and the hypervisor before you get down to the physical host. Same there, we provide all that metrics. If you run this in a public cloud environment, in an infrastructure as a service type of environment, obviously you won't see the hypervisor and the physical host. That's being hidden for you by the cloud provider, but you need to look at everything down to the cloud instance. The cloud instance is in fact the virtual machine running on a physical host somewhere in the cloud. So it's not enough to just focus on the top level, the containers, and looking at how individual containers are behaving. That may be interesting, of course, but from a root cause analysis or from a true capacity and performance management perspective, you need to have visibility of the full stack. Then you need to do cluster monitoring, because as we said before, very quickly, containers became or transformed into a deployment scenario where you have multiple nodes running in a cluster, and you distribute your containers across those nodes using some sort of orchestration software. So you need to monitor the whole cluster rather than the individual hosts to bring the pieces together. So regardless of which orchestration framework you're using, we talked about Kubernetes before. There's OpenShift from Red Hat or IBM nowadays, which has got a lot of attention and a lot of popularity. It's based on Kubernetes as well, or it's using Kubernetes as well, but it adds some extra features and some extra capabilities around the CI/CD concept to Kubernetes. Same with Cloud Foundry from Vityl. It does a similar job like OpenShift, so it provides a more development-friendly layer to the orchestration framework. So all of those are, they are managing multiple different hosts, multiple different nodes that are running containers. So you need to get data from all of those. You need to understand the configuration metadata. So where is the master? Which are the nodes that I need to look at and monitor? And then in those nodes, different type of objects. So they are not using raw containers or just single containers. They are, putting them together in pods. That comes from Kubernetes. In OpenShift, there's a lot of talk about projects and services. So you compose pods together into projects and services. And in order to monitor your services or your applications, you need to be aware of that composition and that mapping of container to pod and pod to project, etc., in order to make sense. So this is a crucial part in getting an understanding of an application and how it's behaving in a containerized environment. So what we provide here, so we have our native data collectors for on-prem usage. So we pick up data from the hypervisor, VMware. If you're running containers on VMs running in VMware, we do the OS level monitoring through Linux and Windows data collectors. You have the container engine in Docker that we monitor. So we provide data from the Docker API. And we also have out-of-the-box integration with Kubernetes and OpenShift to get the orchestration data and to put the pieces together in that way. If you run this in public cloud, we have cloud-native monitors for AWS, Azure, and for Google Cloud. There is a small asterisk on Stackdriver for Google Cloud. Right now, we have a field-developed integration with Google Cloud. In second quarter of next year, we will have an out-of-the-box integration with Stackdriver. So we'll have a fully, or it's already fully supported by the official out-of-the-box version of that Stackdriver integration. So we provide, access to the metrics that the cloud provider themselves provides. Then you can also, of course, put our data collectors, VCM data collectors, inside a cloud instance as well. If you want all the details, if you want more granular data, if you want to, if it's a Linux instance, there's nothing keeping us from picking up the Docker engine API stuff as well. So you can certainly put our data collectors there as well, but you have to evaluate, what your needs are and to what level of granularity you're looking for. There's also metrics or available, or instrumentation available for the different container management frameworks that are provided as services through those providers. So CloudWatch, for example, if you're using AWS with the either the native or the Kubernetes-based container orchestration, you will get some metrics in CloudWatch as well that you can use for that. And then, of course, as always, we provide support for third-party data, and that could come from anywhere. It could come from a public cloud or from an on-prem or any combination of the two. So we have a pretty good coverage of the instrumentation that would be required to manage these types of workload. The next management consideration I would like to mention is the scale. So there's more of everything. There's more objects to monitor. There's the requirements in terms of real time is higher, and there's more relationships to track, because as you have more objects, there will be more relationships between those, of course, and you need to aggregate data up to the level that makes sense more frequently as well. So you need to have a scalable framework for data retrieval and analysis, and this is how we do it. So in Vityl Capacity Management, this is the architecture. So we're using components from Apache that are highly scalable. We can use our own lightweight data collectors. We can also use third-party data sources, as we know. We have a broker that supports real-time data producers. We have a framework that allows us to cluster and scale out to support high rates and volumes in your, that will most likely be the result of your containerization. And then there's an API that provides access to all this data. So if you want to consume this data for any other tools than our purpose-built user interfaces, you can do that too. So having this framework that can cope with these new volumes of data is very important when you want to manage containerized workloads. Next consideration is the lifespan of a container. So the whole idea behind containers, or the way containers have been positioned and the way it's being used, is it's primarily used for scale out, basically. So the containers are more transient in their nature. So you provision new containers, or you start new container images as you need them, and then you retract if the demand goes away. So they're not going to live forever. They're not going to be always there. They're going to be live and die very quickly. So And if you then use these, as we talked about, these automated management frameworks like Kubernetes and OpenShift, etc., that will exacerbate that even further, because that's going to, they're going to do this automatically, and they're going to be much quicker than us as humans to recognize these things and provision or retract containers as needed. So container, you need to be there to see them. You can't sample data once every 5 minutes, because there's a high probability that something happened within those 5 minutes that will go completely unnoticed if you do it that way. So containers in themselves and their management framework normally provides very good observability. There's a ton of data that you can extract, but they are also geared more towards near real time. So more for the performance management, root cause analysis, or troubleshooting type of use case. So they only cover a very short period in time, because the lifespan of a container is normally quite short. So if you want to do long-term optimization and you want to understand how provisioning of new containers or the number of containers varies in relation to your business transaction volumes, etc., you need to store this data somewhere, because otherwise you're not going to get this long trend that shows you how covers your whole business cycles, etc. So there is an absolute need to do that in order to do that, to get that. So this is an illustration of that. So basically, this is what you'll get out of the box. This happens to be Kubernetes. It could be one of the other frameworks as well. So there's a native capability to put the data. There's an API for the cluster service, and there's an API to get data from the different worker nodes as well. This is an in-memory short-term circular data store. So if you query for the what happened the last 5 minutes, it's certainly going to satisfy that need, but it's not meant for long-term use. It may hold a couple of hours of data. It's not deterministic because it's in memory. So as soon as you run out of memory on the cluster service, it's probably not going to save the data for very long. So in order to do this, you need to have some sort of aggregated long-term storage where you tap off this data and put it somewhere so that you can see this long-term trend, you can see the seasonality and histogram data of the data. For that, we're using either you can use our own data store, but there's also a very popular alternative out in the market called Prometheus, which does this for both for Kubernetes and for OpenShift, where we have a default integration as well. The good thing with Prometheus is that it's not included in OpenShift and Kubernetes, but it's prepared for it. So it's very simple to download Prometheus. It's an open source product, and then you can there's predefined or pre-configured integrations with those frameworks. So then it will start to populate this Prometheus database, and then we can use that to report on performance capacity as well, alongside with all the other metrics that we get from the operating system and the hypervisor and God knows where. So there's definitely ways to do that, but you need to think about this, because otherwise you're only going to get this, a momentary, what it looks like in the moment, basically. Aggregation is another important factor. So if you look at how you do forecasting of capacity needs, one component of it is the organic growth. So looking at the long-term or the history of your infrastructure or component or your service or your application, and spot if there's any growth, organic growth that needs to be accommodated for. You also have these days, you normally have a lot of migration activities going into this kind of environment, because applications are being refactored and moved into containers or refactored to containers. And then you have new initiatives going on. So new applications being developed. There's normally a project pipeline with new initiatives, new applications that are going to be launched, etc. All of those needs to be put together in order to understand what your future need will be. This, if this then comes from multiple different workers with different types of container images in pods or in projects, etc., in those management frameworks, you will get this kind of information out. So you can see how much CPU memory each type of container used or each container used, and then you can potentially summarize it by type of image and by pod. But in order to do sort of a compound aggregation of everything that runs of a typical of one type of container image, etc., for modeling and trending purposes, etc., you need to aggregate this data. So again, aggregating this data up to something like Prometheus database will allow you to do this. Otherwise, the native capabilities of just running Kubernetes will not provide you with this capability. Another consideration is the ability to bring context to things. So, this has been a challenge ever since we started doing capacity management. So understanding, translating component demand up to service demand to business demand, because business demand is what we're going to get as a forecast from the business, and that's what we really need to plan for. But in order to break that down to components, you need to understand which components are used for which services underpins different business demands, etc., in order to make this work. So to get this, back in the days when we had virtualization, we had a cluster of hosts that were running VMs. It was hard enough, you had to do discovery, some sort of automated discovery, and then you put that in a CMDB or a service catalog, and you had, a combination of non-virtualized and virtualized workloads, and that sort of mapping in itself was very difficult. If you look at this from a container perspective, it's going to get even worse. There's 4 to 6 times more containers than VMs and on average. This may vary, of course, individually. This spins out of control very easily because now you have a cluster service where you basically just drop your applications and you define how many nodes you want to run it, or how many copies of this you want to do, what kind of replication you want, etc. Apart from that, the whole framework takes care of itself. So it's going to be really, really difficult to understand individual components. What are they actually consuming, and how does that translate into service and business demand? So at some point, you have to give up. You can't connect the whole chain all the way from the bottom to the top anymore. Another way of illustrating this, if we look at complexity, where physical systems used to be our pets, and we took care of them. We moved over to virtualization. They became cattle, so we didn't really care about the individual VMs necessarily as much anymore, and we treated them in a different way. We moved them around where we found that they were up to optimize their placement, etc., etc. Containers are more like a flock of birds. It's really a completely it's a unit of work that you can't distinguish the different components inside of it. Almost it gets out of hand very quickly. That's exactly why we have these orchestration frameworks, and they do a good job at taking care of this. But from a capacity management perspective, it puts a new perspective on things. So basically, we need to learn to settle for good enough, and rather than trying to keep track of everything. So maintaining correct, up-to-date metadata becomes a challenge. There's a scale-out aspect. There's a number of shared components. There's a lack of affinity between an application and the host, etc. So you need to sacrifice some of the detail in favor of the wider scope, and aggregate data into meaningful components. So let go of some of the minute details and aggregate things up to a meaningful level. That's very important. Otherwise, you're going to spend all your time trying to connect the dots rather than actually focusing on the results, which is the forecasts and the risk mitigation and the efficiency aspects of capacity management. So some of the key capabilities for doing this. So from a performance management perspective, obviously you need to do unit testing of key components to understand the general resource consumption of a typical, type of container or type of container workload. you need to provide real-time and historical performance data aggregated by container image and components for diagnostics and troubleshooting. But that's as far as you need to go there. From a capacity planning perspective, it's more about, correlate the aggregated component data with business activity metrics. So understand, how much, if our business activity goes up, how much does that mean? How many new containers are automatically provisioned by my orchestration software to keep up with that? And how quickly are they retracted as the demand goes down, etc. To understand that dynamic between those two. You also need to automate the forecast based on expected demand and apply that to that observed behavior. So once you have an understanding of how your orchestration software handles business activity variability, you need to use that to model. And then you can do detailed planning using workload agnostic capacity modeling techniques like Vityl Capacity Management, capacity plans, for example, to model those individual components, and then to get a better understanding of how they work together and how they are using resources. But to do this, a full-blown simulation of a whole containerized workload becomes very, very, very complex, and it's almost impossible to accomplish. And then, on top of this, you need to provide this as a self-service, because another thing that we also need to take into consideration when we work with containerized workloads is this, change of operating model. So over time, long ago, most organizations were operating in a more of a siloed approach, where you had, technology teams different technology silos. You had siloed teams around applications, and then you probably had a project management office of some sort that were trying to coordinate those different groups and to release those projects and applications that were results of those projects. That shifted to more of a plan, build, and run approach around ITIL 3. That ID was sort of introduced, and then it got a lot of traction over the coming 10 years. And that's how most organizations have been running things in the last 10 years, probably, where you have specialized teams focusing on plan, build, and run rather than dividing them into technology and applications. This allows you to do independent sourcing, etc. So it allows you to outsource or put things in public cloud, etc. So it's a better way of organizing yourself. What Gartner and others are expecting or forecasting that will happen or predicting that will happen in the future is with digital business, there will be even more involvement from the business in how things are being operating. So you need to have a more business embedded operating model. So we talked about this before, the CI/CD movement of continuous integration, continuous development, forces you to push out some of the responsibility for specialized or what used to be specialists were doing now needs to be pushed out to the product teams and people out in the business or closer to the business. So you need to have a more business embedded approach to things. This means that you need to provide your tools as a self-service component. So it can't be just a highly specialized tool that a few selected people in the organization understands and can use. It needs to be made available to a much more wider audience, and that means that you need to focus more on prescriptive advice, because they are not going to be the specialists. They need to have specific advice around what to do. It needs to provide more automation, and it needs to provide, of course, these self-service capabilities that we talked about. So that is also something. It's not necessarily tied to containers as a technology, but it happens to coincide with that whole movement, and those expectations will be, if they're not already there, they will be prevalent relatively soon. And it's important to start to work in this direction as well, for capacity management. So what is the incremental value of using analytics? So this is the sort of decision-making model. So you have data, you analyze that data, you make a decision, and then you take an action on that. If you pull that apart, there's a number of different options. So basically with analytics, the way we do it, you can provide more support for this. So you can take your data, avoid the human input, and move all the way up to decision or even action much faster. So taking a descriptive approach, it requires a lot of human input and a lot of human experience in order to take it through to decision and then an action. And as you move up this stack, prescriptive is basically telling people what they should do based on a certain problem that has been presented. So a problem has been defined or identified or forecasted, and based on what we know about it, this is what you should do. So taking it all that way up to action, that's really what you need to strive for in these kind of more business embedded type of capacity management environments. So the required skill is higher, of course. So you need to automate it because you can't expect that skill, but also the business value, of course. I mean, if you can push this out to a wider set of people that are more aligned with what the business actually needs, etc., that is going to do better for you. So you can have more people doing that kind of qualified analysis. And then, of course, this requires you to have some level of operational maturity. This, we have a maturity concept that we use for this, where we take customers through these different steps of maturity in order to get to the point where you can actually have all the different sources and all the different information available and all the different processes available to do prescriptive and predictive and prescriptive analytics in your organization. Okay, so we're going to have another poll here. So this poll is around how are you managing or planning to manage your containerized environment. So first one is containers managed using native controls. So basically using Docker and operating system scripts, etc. Second one is Kubernetes. Third one is OpenShift, and fourth one is the classical other one that probably entails things like Cloud Foundry, Vityl, etc., etc. Could also be container management workloads available in public cloud, I guess. Okay, so I'll give you a few minutes more, a few seconds more. Okay, I'm going to close the poll here. I don't get any more response now. It looks like it's stable. Okay, so I'll share this one. Okay, so I hope you can see the results now. So 14% says that container is managed using native controls. So with native controls, I meant, as I said, any type of script or operating system features that would come with Dockers or with the Linux operating system. Third of you said Kubernetes. Another third of you said OpenShift. So that goes to show how popular OpenShift has become. And then a third of you said other. So what that includes. Okay, so this is sort of the expected result, I would say. Note that OpenShift is built on Kubernetes, and a fair amount of the others are probably also built on Kubernetes or uses Kubernetes under the hood. So Kubernetes is definitely a major component in any type of containerized container management approach, I guess. Okay, I'm going to hide this, and I hope you can see my screen now. Yes, it looks like you can do that still. Okay, so to summarize this, we're running out of time. So a few key points. So if anyone thought so, it's not the case. So shifts, container technologies is more than just another layer in the software stack. It's not just another technology that you're picking up. It has a big impact on how you develop your applications, how you run your applications, and how you manage risk and efficiency of your applications. It means a lot of it raises the bar in terms of speed, scale, and complexity. There's more components. There's quicker components that lives for a shorter time, and those components still needs to come together in order to make sense. No one in the business is going to tell you that we expect container type A to grow this much next year. They're going to tell you, about your business applications, business services, and then it's your job to break that down to types of containers or pods or projects, etc., and then manage those or understand how the impact of that demand will be for those. Containers are not going to sweep the floor and completely remove a need for other technologies. It's going to be part of your hybrid IT management. So you still will have physical systems or virtualized environments or public cloud-based environments, etc., etc. So it's another pie to that, or piece to the pie, sort of the whole pie of different types of technology that we need to manage. And that's why it's important to, as far as possible, use the same management framework, the same tools, etc., to do this. So have a single pane of glass that can see your container workloads side by side with, the rest of your IT stack. And most likely, you'll have applications that covers both multiple different parts of this. So the full stretch of an application may go from a physical host over to VMs or containers or public cloud instances, etc., etc. So it's important to bring all that together. This whole thing happens to coincide with other trends in the business or in the industry where the adoption of or the digital transformation, or whatever you like to call it, means that you have to push out some of the responsibility for the things you're doing to people that are closer to the business, or that are in the different product lines, or different owners of the different applications, etc. They will expect, or they are expecting to be able to do a bit more on their own. So provide some sort of self-service around capacity management becomes a key aspect as well. So this is something that definitely we see a lot with our customers, and this is something that needs to be, if you're doing this transformation or this, overhaul of your solution stack based on containers, you should take this into consideration as well to make sure that you provide for that need as well. Okay, so with that, thank you for your attention. So I still believe we have a few minutes here, so I'm gonna see if I can find any questions in the chat window. If you just give me a second here, I'll pull up the chat window. Okay, I have a couple of ones here. So yeah, so are you using native APIs to monitor OpenShift? Yeah, okay. No, we are not. We're using, as we said, I mean, there is an API, of course, to OpenShift that you can use to pull out some instrumentation and metrics, but we actually use this, I mentioned Prometheus, which is an open source monitoring project for, among others, OpenShift, also OpenStack, Kubernetes, a lot of other technologies. We found that very useful. It's very powerful. It's very simple to integrate with OpenShift. It comes, OpenShift has a predefined integration with Prometheus, and we then use the Prometheus data. So we don't use the native APIs. We actually use Prometheus to get to the data. And then there's one more question. So do you use sidecar containers in your solution? No, we don't. So sidecar is basically when you put your monitoring software in a container by itself, and then you use that to instrument the nodes in the cluster, for example, or monitor other containers. No, the way we do it, I mean, we have the native data collection from the operating system and the metrics that provides to us, together with the API of the container engine. And then we use the different orchestration or management frameworks to get the data. We don't use sidecars at all, actually, in our solution. Those were the two questions I had, I believe. Yeah, there is one other one. Sorry, I found that now. So what does Vityl Capacity Management provide that I won't get from metering provided by the vendors? So Docker, Kubernetes, etc. Okay. Yeah, so what we do, what we provide that you won't get from those, obviously, you get a single pane of glass. If you have one of those sources or a couple of those sources, you still need to bring it together. You need to be able to correlate those, synchronize that data, et cetera. None of that is simple. None of that happens by itself. So there's a lot of work going into bringing that data together and make it synchronizing it and make it appear like or allowing you to correlate across those different. So basically what we do, we have this full stack monitoring approach where we monitor everything from the operating system via the hypervisor operating system, container engine, container orchestration software, all the way up, whether it's on-prem or whether it's in cloud. I guess that's the big difference. So it's basically one single source of information where we can integrate with all those. And then, of course, on top of that, we have our advanced analytical capabilities, so we can do predictions and forecasts based on what if scenarios, etc., that you won't be able to do with those. So that's how I would position us compared to those, sort of built-in metering that comes from the vendors. Okay, that's all we had then, I guess. There's no more questions. So with that, I would like to thank you for your time. And if you have any other questions or any, want to discuss anything else in detail with me or anyone else at Help System, I encourage you to reach out to us, of course, as usual. And, I hope I'll see you back in one of these webinars in the not too distant future. Thank you very much.